Okay, today I'm going to teach you how to do a calculator overflow problem. And the way that you can spot a calculator overflow problem on the test is that if you try to do it, so let's look at this problem right here. If you try to do a problem like this on a calculator, so 1,243 enter to the 1,466 power, you will get overflow, and then it'll flash over to 1 times 10 to the 500th. That's not the actual answer. What that's doing is the calculator is saying that's as close as it can get. So what we're going to have to do is learn how to take care of these kind of problems. Now, the first thing we're going to do is, let me talk real briefly about logarithms. Don't write any of this down, but if I took the number 100 and I took the log of 100, it will turn that into 2. So, for example, if I do 100 and I log that, it'll say 2, because that's the power of 2. 100 is the second power of 10, right? 100 is the second power of 10, not 2. All right, so all logarithms do is turn numbers into powers of 10. So the first thing we're going to do is we're going to take the log of the base number, and we're going to multiply that by the other number. Now, I'm not going to go into why that works right now, but that's what we're going to do. So if I take the log of 1,243, take the log of it, I get 3.09. So that's the power of 10 that it is. I'm going to multiply it by 1,466. All right, I get that number. Now here's the key. This is the part that some people mess up on. What you want to do now is you want to show. So you hit the yellow enter key. Let's try that again. Yellow enter key. And you get a number that pops up, right? That number, you want to look at the whole number. The whole number part of that number, 4536.49, blah, 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 blah. You want to write down that whole number part, 4536. In your answer is always made up of two pieces, right? Some number times 10 to a power, right? That number to a power, what I'm going to write here is I'm going to write the whole number part. And the whole number was 1,436. So that becomes this, 4,536, I believe is what it was. Let me check it one more time. Yes. All right. I'm going to write that down. So that's my power of 10. I'm halfway there. Next thing I want to do, I want to get rid of everything in the number but the decimal. So what do I have to do to 4,536.49 to get rid of the decimal? Well, subtract 4,536. So that's what I'm going to do. I'm going to subtract 4,536, subtract that, and now all I have left is a decimal, because a number to the negative 1 power means it's a decimal, right? Because you'd move the decimal one place to the left. So that's 0.459. Now, at the beginning of the problem, we logged, right? At the beginning of the problem, we logged. So at the end of the problem, we're going to 10 to the x. We're going to undo the logging that we did at the beginning. So we're going to take that number, and we're going to 10 to the exit, and we get 3.12. And that is your number. All right? So what did I do? One more time. First thing I did was I took the log of the whole number, right? Then I multiplied it by the power. Then I showed. And after I showed, I looked at the whole number, and that's what I wrote here, right? Then I got rid of that number, so I subtracted 4,536 from the number, and I 10 to the x that number. All right, so I don't expect you to know how to do that yet, but let's try another one. All right, so second problem. What are we going to do first? Well, this first thing we're going to do is we're going to take the log of 513. We're going to multiply that by 1,286. So 513 logged 1,286 times, right? And now I'm going to show. So yellow, show, and I'm going to write down the whole number part, 3485. That's my power of 10, right? Some number times, I'm going to run out of room here, so let me write it down here. Some number times 10 to a power. What's that power? It's whatever the show is. 3,485. So I'm going to write 3,485 485. That's my power of 10. I wanted to get rid of everything but the decimal. So right now, what do I have? I have 3,485.21. I just want the 0.21 part, right? So I get rid of 3,485 by subtracting 3,485. I'm going to subtract that, and I get that number, right? I got everything now but the everything is gone but the decimal part. And remember, at the beginning of the problem I logged, so at the end of the problem I 10 to the x. And I get 1.63. Now let me point something out to you right now. Notice in this problem that these are to the 0 power, times 10 to the 0 power. I need that to be to the 0 power, because if it's not to the 0 power, then I'm in trouble. All right? So, next problem. First thing I do is I take the base number, right, and I log it. Well, pi, if I don't know what pi is, I could do pi to the first, right? That would tell me what pi is. Sometimes on your test, you'll see like e to a number, like e to the 59540, right? If I don't know what e is, do e to the first. That'll tell me what e is. So I'm going to do pi, right? And if I don't know what pi is, I can do pi, hit the pi key to the first power, right? And there's pi, right? What do I want to do to it? Well, I want to take pi and I want to log it, right? Times 9540. So log pi, 9540 times, I get that number, 4.74. I want to show that. And remember, what do I want to write down? 4742 is my power of 10. So this is going to be 10 to the 4742 power, right? And I still need my base. All right, so 4742, I want everything but the decimal to go away. So I need to subtract 4742. 4,742 needs to be subtracted. 4,742 needs to be subtracted. I get that number. That is the decimal part that was left from that original number. And remember, I logged at the beginning of the problem, so I want to 10 to the x at the end of the problem. And I get 6.45. Once again, let me focus on something here. That power of 6.45 needs to be to the 0 power. If it's not to the 0 power, you're going to have to fix your problem at the end. And I'll teach you how to do that in a few minutes. All right, another one. So, negative 3,321 to the 1,254th power, right? All right. When you have negatives, you can't do logarithms of negative numbers. If you try it, if you take 200 negative and you try to log it, it's going to say log negatives. You can't log negatives, all right? So we got to do something else here. Well, the first thing you do is just look at the number. I'm not going to go into detail right now, but if the negative is outside the parentheses, then it just makes the answer negative. So you know right now that this number is going to be negative, right? Hopefully you know by now that negative 2 squared is negative 4 and not 4, right? Because if the negative is outside the parentheses, that's just negative 4, right? If the negative is inside parentheses, like negative 2 squared like that, then it is 4, all right? So if the negative is outside the parentheses, then it is always going to be a negative number. So on this problem, the easiest way to do this is to ignore the negative. Just know that the number is going to be negative. Make sense? So I know this number is going to be negative at the end, so let's hope at the end of this problem I don't forget to do that. All right, so ignore the negative, and we get 3,321. What are we going to do to it? We're going to log it. Then we're going to multiply that by 1,254, right? We're going to show. We're going to show, what is it? 4415. So that's my power of 10, right? So this equals, actually, let me move it over here a little bit. This equals some number times 10 to the what? To the 4415. Right? Now I want to get rid of everything, once again, that is not the decimal. So everything that's left but the decimal needs to go away. So I'm going to get rid of 4415. 4415. I'm going to get rid of it, so I subtract it. And I get 6.71 times 10 to the negative 1, which is a decimal. And then remember, logged at the beginning, 10 to the x at the end. And I get 4.69, right? 4.69 times 10 to the 4415 power. And then don't forget, what did we say at the beginning of this problem? This number has to be negative, right? So, oops. This number has to be negative, so it has to be negative 4.69 times 10 to the 4,415 power. Humongously small number, right? All right, next problem. On this one, the negative is inside the parentheses. So here's what your brain needs to do. If I take a negative number in parentheses to an odd power, it will always make a negative number, right? So if I took, let's say, negative 3 to the 5th power, I know it's going to be negative because the power is odd. If I took negative 3 to the 10th power, I know automatically it's going to be positive, right? So the number's in parentheses. So what am I going to have to do first? Well, I'm going to have to figure out if this answer is positive or negative. Well, a negative number to a positive power will always be positive. So the best part about this problem is you can ignore the negative because you know the answer is going to be positive. All right? So we just do this problem now just like a normal problem. So 5,703, I'm going to log it. All right? Multiply that by the power, 888 times. Then I want to show, right? I want to show, oops, I didn't press show. I want to show 2,449. I'm going to write that down as my power of 10, right? So this equals 10 to the 2,000, I hope I wrote this right, 2,449, right? Get rid of the 2,249, so 2,449 minus, now what do I have left? Just a decimal. At the beginning of the problem I logged, so at the end of the problem I 10 to the x. So yellow, 10 to the x, and I get 1.74. Now one more time, look at that number. Is the power 0? Yes. Good. That's the way I want to do this problem. All right? Next one. Actually, this problem's not bad. I think I might just skip that one because it's very similar to the one before. Let's go to this one. This problem right here is very tricky. It's a number to a negative power. All right? We're going to treat this one just like normal. So we're going to log it first. But there's a little twist at the end of this. And I'll tell you what, we go to these competitions, my teams go to these competitions all the time, and they have overflow problems with negative powers. And about 50% of the time, the person who wrote the test has the wrong answer on their own test because they actually don't know how to do their own overflow. In the last year or so, it's gotten a lot better, but previous tests, about 50-50, they messed them up. So, first thing, we're going to treat it like a normal problem. 5,497, we're going to log it, right? We get that. We're going to multiply that by the 1157. So 1157 times, right? We get 4.31 times 10 to the 3rd, right? That can't be right. Somewhere I made a mistake. Let's try that over. 4,297. I'm going to log that. Times 1157 times. Maybe I did do it right. Yeah, I did. All right. I'm going to show. So yellow, show. Let's try that one more time. Yellow, show. All right, there's my number, right? What I don't see here, I'm wondering if I forgot. Oh, I did. No wonder, Gillespie. You missed it. There's a negative there. So let's try this for the 3rd time. 5,297 logged times 1157 negative. I want to multiply those. There we go. There's the negative I've been needing. Negative 4.31. All right, this is important. I'm going to show, and it says 4308. But it's negative. So I'm going to write this right now. I know that the power of 10 is, what did I say? 4308. So I'm going to write negative 4308. It's actually going to be wrong in a minute, and I'll fix it, but I want to just write it first. All right, now here's the tricky part. Every time before, we wanted to get rid of everything but the decimal. Here's the problem. This number's negative. So if I want to get rid of everything but the decimal this time, I would not subtract 4,308 because that would actually just make a bigger negative number with the decimal still there, right? How do I get rid of negative 4,308? The way I get rid of 4,308 negative is by adding 4,308. So every problem before we've been subtracting to get rid of it. This time we're going to add to get rid of it, right? So there we go. There's our number. Just like before, we're going to 10 to the exit at the end. And this is the tricky part. Here we go. Notice, okay, so the thing I was just saying here is you want to look at this number. This is the first time that the power, E's power was not 0. It was -1. So here's what I'm going to write. I'm going to write 1.98 times 10 to the -1. And then I need to look at this whole problem. You can see why this one's trickier. Look at that whole problem. If I have 1.98 times 10 to the -1 times 10 to the -4,308, what do I really have? Well, I have 1.98 times 10 to the -4,309th power. So what will happen on the test is, remember I told you at the beginning of this question that so like I was saying, these kind of problems, if you look at the answer key, about 50% of the time they keep the 8 there. So the answer key will have an 8 there. The problem is they forgot that this power was a -1, so they had to add one more negative power to the answer. So the actual answer is 1.98 times 10 to the -4,309. Remember the special trick here. Let me go over this one more time. The special trick is, I'm going to erase most of this here. Let's make that negative look nice and pretty here. The special trick is when you log the 4,297 and then you multiply it by 1,157 negative, and you show, you get 4,308, but it's actually negative. So you're going to write, this will be 10 to the -4,000, I'm sorry, I don't remember what it was, 4,308 negative. But we're going to get rid of the 4,308, not by subtracting, but by adding this time. Every other problem so far we've gotten rid of by subtracting, but this time we're going to add. And then just like before, we're going to 10 to exit. And remember, it has a -1 power. So, sorry about that. We had an announcement here. So because it's to the -1 power, that's 1.98 times 10 to the -1 times 10 to the -4,308 power, which becomes 1.98 times 10 to the -4309 power. Don't forget to add 1 to that power. All right, last problem. So this last one, what I want you to do is basically ignore the 32 at the beginning of the problem. We're going to deal with the 32 at the very end of the problem. So the first thing we're going to do is do this problem like normal. We're going to log 1,581 times 1938. All right, so let's do that. 1,581 logged times 1938. All right, we're going to show, right? Just like every other time, we're going to figure out what that number was. 6199, right? So this is going to be, actually, I'm just going to write the 10 here, times 6199 power, right? We're going to multiply it. All right, we want to get rid of everything but the decimal. So how do I get rid of positive 6,199? I subtract 6,199. All right, 10 to the exit. I get 3.39. All right, now here's the new part. Now I'm down to 32 times 3.39 times 10 to the 6199 power. All right, so I'm going to multiply. Here's the next step. I'm going to multiply the 3.39 times the 32. So I have 3.39, 32 times, and I get this new number. I get 1.08 times 10 to the second times 10 to the 6199. All right? So I get that new number. What is that really saying? Oh, well, that's easy. It's really just saying 1.08 times 10, power of 2 plus the power of 6199 makes the new power of 6201. And there you have it. 1.08 times 10 to the 6,201 power. So all you do at the end, because you have e to the positive 2, that's times 10 to the 2. You're just going to add 2 to the power at the end of the problem. All right, there you have it. Calculator overflows. I hope this helps you. Good luck.